Okay, so this is number 66. It says a voltaic cell using the following reaction operates at 298. Here's the reaction. It says what's the EMF of the cell under standard conditions. And so for this one, I would do cathode minus anode, which is right here on the red cat sheet. And then I would do the one that is reduced, which cerium starts at +4 and goes to +3 first. And if I look up cerium on here, I get cerium as 1.61. And then I look up chromium, because that's the one that's oxidized. It goes from 0 up to +3, and that one is -0.74. So I end up with 1.61 minus a minus 1.74, which this is my EMF, or my voltage, at standard conditions. Okay, then it says what will be the EMF of the cell, and then we change the concentrations. And so I'm going to use the Nernst equation here now. The Nernst equation is right down here. E of the cell at non-standard conditions is equal to E cell at standard conditions minus 0.05916 divided by n log of Q. And so here's my E standard, which I'd take the 2.35 and put down right here. And then here's my 0.05916, which results from combining R and T. And then I divide it by the number of electrons transferred. And so here's how I figure that out. I take one of the half reactions, and I decide how many electrons is it going to take to balance that half reaction and make the charge be the same on both sides. And there's 3 moles of electrons transferred, so N equals 3 down here. And then I take it times the log of Q. And Q, remember, is products divided by reactants to the power of the coefficients. And so looking at the problem, my CE plus 3.1 is over here. And then my chromium is 0.01, that's over here. Notice I raised this one to the third power, this one to the first power. And then I take my chromium that is on the, my cerium that's on the reactant side, cerium plus 4, 3 molar, and I put that on the bottom and raise that to the third power because there's a 3 in front of it. The chromium solid is a solid, and remember solids and pure liquids don't go in an equilibrium constant or Q expression. So then I think I did this math right. I did this portion right here and got 3.7 times 10 to the -7th, logarithmed that, and I got -6.43136. And now I need to take that and multiply it by 0.05916, and then divide that by 3. So on my calculator, and people that are live here, if you wouldn't mind doing it on your calculator as well, here's my 6.4, and then I'm going to multiply that times 0.05916, enter. And then I'm going to divide that by 3, number of moles of electrons transferred. And that number ends up, this whole thing right here, ends up being -0.1268. Did you guys get that? You can just nod yes. Okay. And then that number is subtracted from my standard potential, which was 2.35. So it's minus a minus here, so I would do 2.35 minus second answer, and I would end up with 2.47 volts for that one. So notice the voltage increased just slightly with those concentrations. Part C is almost exactly the same, except this time I have a different Q, and you can see this time I have 2, I have 1.5, and then I have 0.01 down here for my CE products divided by reactants. Yes, this is my reactant right here, 0.01 to the third power. So I'm going to calculate Q, and then I'm going to log it, and I have some colleagues here that are going to do the calculating with me. So 2 times 2 times 2, that gives me this part right here, times 1.5, enter, and then divide that by 0.01 to the third power, and I think I get a really big number. Does anybody agree with me for this part right here? A couple people do? Okay, now I've got to log that. So log, regular log of second answer, And so now I get a big number there, 7.0, and now I take that times 0.05916, and then I'm going to divide that by 3 moles of electrons transferred, and so now my E, which was 2.35 minus a positive 0.139, now I'll end up with a voltage that's less than, so it would be 2.35 minus second answer, I get 2.21 volts for that one. So I can see that in this reaction I end up with a lower voltage, whereas in this one I ended up with a higher voltage, and I think that does number 66.